You can read the information sheet. It's uploaded under the folder miscellaneous. All right. Okay. So last week we talked about Chebyshev inequality. In fact, the most common questions that we encounter in probability is to answer this question. What is the probability X between A and B, for example? Now, in order to evaluate this probability, you need to know the distribution of X. Remember, the distribution of X will tell you everything about the random variable X. So, the X can be discrete, all right, can be continuous, random variable. It depends on the range of X. So, usually the distribution is described by a function f of x. For discrete case, it can be represented by table form, all right? But basically, you need to know that. So now the question is, if we don't know the distribution, we only know two things about the x. The expectation of x, and usually this is referring to mu, and the variance of x, which is sigma squared, or just the sigma. Okay, we know sigma, we know mu. So can we get the probability of x between A and B? Again, the answer is no. We don't know. But at least we are able to find a bound for the answer. So that is what Chebyshev inequality is about. So the Chebyshev inequality states that the chance that x deviates from the mean or within certain distance from the center mu greater or equal to, all right, just make sure, okay, greater or equal to k sigma, which means that if this is mu, this is the distribution, so x between this mu minus k sigma or this point, mu plus k sigma. So this is k sigma, this is k sigma, so this point is mu minus k sigma. So in other words, x falls within this range, all right, I'm sorry, greater or equal to. So in other words, falls outside this range. All right, it's this part. It's this part. All right, I'm sorry. All right, so it is bounded by above by 1 over k squared. So this is what Chebyshev inequality is about. So it's saying that the chance that x falls outside the range of plus or minus mu plus or minus k sigma is less than 1 over k squared. All right, so this is an inequality that holds for any distributions that have expectation and variance. All right, now of course, if k equal to half, for example, this inequality still holds. All right, because in that case, it's simply saying that x minus mu within half standard deviation is less or equal to 1 over 0.5 squared, means less than 4, less or equal to 4. This, I don't need Chebyshev inequality. I know that the probability is less or equal to 1. So this, in this case, the Chebyshev inequality is useless. All right? It gives you a bound. It's too big that no help. All right? So usually k has to be bigger than 1, or ideally maybe with 2. All right? So in other words, if I apply the Chebyshev inequality, I will say that probability of x within 2 sigma. This simply means that x is between mu minus 2 sigma and mu plus 2 sigma. All right? Then This one is less or equal to 1 over 2 squared, or 0.25. All right. So at least when k equal to 2, I have this. I don't know what the probability of x minus, the mod of x minus mu is greater or equal to 2 sigma. But I know that the probability cannot exceed 0.25 or 1/4. So that's the idea of Chebyshev inequality. All right, so now let's look at an example. So now the number of telephone calls, x is a random variable, all right. It represents the number of calls in a day, and the expectation of x is 14, and the standard deviation of x is 0.5. So we are asked, what is the probability of x within 7 and 21? Okay, so we know that if I minus 14 of each of them, each side of the inequality, all right, then so it's equivalent to minus 7, x minus 14, and 7, which is the same as saying that x minus 14's absolute value is less than 7. Remember this fact. Absolute of A less than a number B means that the value of A is less than B, but A cannot be too big a negative number. It has bounded below by minus B. So that's what I wrote down here. So in other words, we are looking at the probability of x deviate from the mean within 7. So the next question is, how about this range, 7? How many standard deviations are there? So this, because the standard deviation is 2.5, so this is equal to 2 sigma, or the k is equal to 2. All right? So this is how we get it. So this is 2, this is sigma, this is mu. All right? So the probability bigger than outside the range of mu plus or minus 2 sigma is less than 1 over k squared. So within that will be greater or equal to 1 minus 1 over k squared. So the answer is 3/4. All right? Okay. How about another example? So x, all right, is given by this no functional form, but expressed as a table. So this table tells us all the possible values of x. X takes the value 0, 1, 2, 3, 4, 5, 6, with the corresponding probability associated with it, 0.1, 0.15, and so on. Now, make sure, all right, make sure that this is a well-defined probability function, which means that whether all these numbers are bigger or equal to 0, obviously they are. And second thing that you have to check, make sure that this adds up to 1. All right? So what happens if all this number, all this probability, all this f of x do not add up to 1? What to do? So what does it mean? There are two possibilities. All right? One is that there's a typo. Then send me an email. All right? In the test, then raise your hand. All right? There may be a possible potential typo. Secondly, read the question carefully. Sometimes, this one is obvious. It's so simple. But sometimes it may represent that there's some others. For example, the previous question, number of calls, for example. All right? So I tell you that, okay, 0 calls, 1 call, 2 calls, up to, let's say, 20 calls. And the probability of all these possible values do not add up to 1. So in other words, there is a probability related to those beyond the list that you see. So in that case, it's understood that you have to add in this extra category, maybe 20 or 21 and above, with the probability which make all the sum of all the probability equal to 1. All right. So for example, this instead of 0.1 is 0.05. Then all this number does not add up to 1. Then what does it mean? There may be a possibility that there is 7 or more with a probability of 0.05. All right? 7 or maybe 7 or more. So that it adds up all the probability equal to 1. Okay. Luckily, they add up equal to 1. No typos. All right? So we can work out easily the expectation and the standard and the variance. So the standard deviation is the square root of this number, and round to two decimal places, I got 1.54. So if I apply the Chebyshev inequality, the probability of x within 2 standard deviation of the mean should be less than 0.25. So in this case, remember, mu is, what is mu? Huh? Yeah, okay, so the mu is 2.64, and this standard deviation is 1.54. So in other words, if I expand it, then, okay, so it's equal to x less than minus 0.44, and x greater than 5.72. All right? So x minus 2.46 between 1.54 or minus 1.54. So therefore, it's equivalent to x less than 0.44 and so x greater than 0.44 and x less than 5.7. Oh, sorry, huh? Where's the 2? Huh? 2. All right. So it's minus 0.44 and 5.7. So the chance that x between these two numbers is equal to x minus mu between greater or equal to, sorry. I a little bit confused you. Huh? So it is greater than, here is within the range. All right. So let's work out this one first and take 1 minus it. All right, so this is equal to 2 times 1.54. But anyway, so if this is the probability, right, and we are saying that this probability is equal to, this probability is the same as probability of x less or equal to, now, if x is less than minus 0.44, remember our, so minus 0.44 plus probability of x greater or equal to 5.72. Why I can write it like that? Huh? Because this is simply saying that this is event A and this is event B. It's A probability of A union B. And these two are mutually exclusive. Therefore, I can add the two probabilities together. So, Chebyshev inequality is saying that this one is less or equal to 0.25. But in fact, if I know the distribution, which is given to us, all right, so this is the same as probability of x less or equal to 0.4, so it's less than 0, all right, less than 0, plus probability of x has to be bigger than this number, but remember x are are discrete. X is a discrete random variable. So this is equal to this. This one is 0. X cannot be less than 0. And so this is x equal to 6. X equal to 6 is 0.04. So what does that mean? It means that if you know the distribution as the distribution given in the question, then the probability of this should equal to 0.04. While you apply the Chebyshev inequality, what you can say is that, okay, this probability cannot exceed 1/4. So you can see that the bound that I have from the Chebyshev inequality is very, very different from the actual answer. All right? From the actual answer. The actual answer for this question, for this example, is 0.04. But Chebyshev inequality just tells you that it is less or equal to 1/4. All right? So the Chebyshev bound is too conservative. All right? Okay. So now, how about in this example, example 1? If you are asked, what is the probability I just changed 7 to 6. Right? So, how to proceed? So I still apply the same thing. So it's 6 minus 14, x minus 14, 21 minus 14. So this is 7. This is x minus 14, and this is minus 8, right? Then what? So how can I express this into x minus 14 less than k sigma? Hey, this is not in this form. This is minus 8, this is 7. So how to do? How to find the answer? Or find the, at least give a bound. How can I make it the two inequalities, the two ends, same number and different in sign? So there are three possibilities. One is arbitrarily choose two numbers, irrelevant to 7 or 8. We shouldn't do that. The other one is 7 and change the other to minus 7. So that both are the same. The two. What I mean is that change this. Either change this to minus 7, so that I have 7 and minus 7. The other one is change this minus 8, change this to 8. So that both in ends of these two inequalities are 8 and minus 8. So their magnitude are the same. Which one should we use? 7 minus 7, 8 or minus 8? I leave it to you. Whatever you choose, you must be able to tell why you make such choice. It's not toss a coin, head or tail, and then choose it. All right? There must be some reason. And the reason is something to do with the inequality, the upper bound. Okay, this one is the lower bound because we are talking about x minus mu less or equal to k sigma. All right? So you think about it. And even if you don't think about it, I will ask you in the tutorial questions. All right? But don't wait until the solution or the tutor discuss it. You should work on that. Okay. Now, let's move on to chapter 3. Okay. Chapter 3 about two-dimensional random variables. The idea is similar to one random variable case, except that now each each individual, okay, let's recall what is one dimension. It's something like this. We have a sample, we have a population, or the sample space S. Each one is a sample point. Then we have this function to map the value to a real number. So this function is called a random variable. All right? So for example, we toss a coin. So there are two possible outcomes, two possible sample points, head and tail. So I can map head to 0 and map t to 1. All right? Or I toss a die. All right? So the sample space is 1, 2, 3, 4, 5, 6. All right? So I map it to the real line or real numbers, again map to 1, 2, 3, 4, 5, 6. All right? Or the sample point is the outcome of tossing 3 coins. So I have 3 heads, 2 head, 1 tail, 1 tail, 1 head, 2 tails, or 3 tails. All right. So then this may be the x is the number of heads. So if you see something like this, it will map to 3. We're talking about the number of heads. All right. So h of s equal to 3. If you have this one, then map to 2, and so on. Now we may do the experiment. The outcome, all right, can map to 2 different functions. All right. So, for example, like height and so maybe there are two characteristics that we're interested in the same outcome. All right. Let's say I select one of you, so the experiment is selecting one of you, but there are more than one characteristic of you that I'm interested. Simple example is maybe your CAP, all right? If you're not the first semester here, so you have a CAP, and maybe I'm interested in also maybe how many modules you take in this semester, or, all right? So each individual, all right, the sample point here is this individual, and then there may be 2 different possible outcomes or 2 possible functions or 2 characteristics that we're interested in this individual. All right? So that leads to 2-dimensional random variables. So we talk about the John probability function. All right? So, and because of 2 dimensions, we also talk about marginal distribution and conditional distribution. All right? So basically you can think of it like this. The 2-dimensional is like x equal to certain value and y equal to certain value. And, all right? And then of course, although I have x and y, I may be just interested in this one. This is called marginal. Then, of course, you see, these are all events. And, of course, finally, there's this one. What is this? What's the name for this? Conditional distribution of x. That means given y equal to this particular value, how does x behave? So this is, I want to know how x behaves. So what is the random variable x behaves? This one, given y equal to x, y equal to little y, how does x behave? Or the distribution of x for different value of x. All right. Are these two the same? The answer is no in general. When they are the same? You forgot what we learned in chapter 1. When these two are the same? The event that you condition is not. That's not so, right? So in other words, it doesn't matter whether y equal to little y or not. All right, it can equal to little y1 or equal to little y2 if still the same. Then we call x and y are independent. So all this we'll discuss again. All right. So we combine what we learned in chapter 1 as well in chapter 2. So chapter 2 will cover random variable for one random variable, one only. But then for chapter 1 we talk about all these conditional probability. All right. So we are looking at all this. Okay. So we are going to talk about two-dimensional random variable, joint probability function, and joint probability density function, marginal distribution, and conditional distribution. This is one thing I forgot. Independent random variables and the expectation. So all this that we learn it in or discuss them in one random variable case in chapter 2, now we expand it to two random variables. Of course, it's much harder because once you have two random variables, it gets more complicated. You heard about this, 1 plus 1 is greater than 2, right? Not mathematics, but why I say that? Because you cannot just look at an individual. There is an interaction between x and y, the two random variables. So it makes things more complicated. When we say that they're independent, then it's easy. So whatever y have or whatever happened to y does not have any relationship with x. So that makes life easy. But in general, x and y are related. All right. So it's more complicated. All right. Okay. So there are many experimental situations where more than one random variable are of interest to the investigator. Like we study height and weight of a person chosen from a certain population. So in this case, the sample point is each individual. So individual, once we select, we measure its height and weight. All right. So another one is we look at a piece of copper that we got, measure its hardness and tensile strength. All right. Okay. So here's the definition of two-dimensional random variable. So there are two functions, x and y, such that each of them map as the sample point in the sample space into a real number. So in other words, if this is the sample point, a sample space, this is a particular sample point. So we map using x and also map this using y. So now I have an image here, xs, and ys. Ys. All right? Maybe better do it this way. This is okay. This is a sample space. This is S. I map to the real line. Two-dimensional. R squared, two-dimensional. So this is little s. So this one map to through x and y, map to xs and ys. What does it mean? It means that this one S, this is my HS, and this one is my YS. So in other words, this point S in the sample space, I'm going to map it to the real plane, two-dimensional, map it on a point on the real plane. So the x coordinate is the value of this random variable xs. And the y coordinate will be the random variable y at on this sample point S. Okay? So that is called a two-dimensional random variable, or sometimes referred to as random vector. So this is the order pair. So each component are random variables. All right? And remember that the random variable takes the values. So x takes certain values, y takes certain values, and they are referring to the same sample point in the sample space. So in other words, remember it has to be like that. All right. This is a function. Add on the sample points, and this is a real number. Similar for this one. So they are common with a common S. Okay. So the range space, this one and this one, okay, is called the range space. So what I just mentioned is the real two-dimensional real plane. So of course, this definition applies to more than two random variables. So just now we say that X, an order pair X, Y, all right, such that, so HS map to S, little x, and YS map to little y, or XS, or I should write it like this. This means that I have two functions add on this particular point S, so that I have the answer is equal to X and Y. So in other words, H applied to S gives you X. Y applied to S, S gives you Y. Gives you Y. All right. Okay, if you don't get it, wait for an example. But this is what we defined as a random variable. Random variable, the way that we look at it, one way to look at it is it's a variable. That means it takes certain values, a bunch of values, and it's random because associated to the value we have a probability or probability density function. But another way to look at it is that this random variable in fact is this is more rigorous. It is a function. A function. And what is a function? You know what is a function? Function is just like matchmaking. Put a boy, a girl, put it together. Functions like that. Put the S, then a real number, put it together. That is a function. But it's not just one matching. It maps everyone in the population. All the S in the sample space. This S mapped to this value. This S mapped to this value. So this is a random variable. All right? Okay, so two dimension, you just have two functions. So extend it to K of them, all right, or N of them. So you have X1, X2 up to Xn, and each one operate to the sample, a particular sample point, and you will get these values. All right? I hope you understand the notation. The big capital letter represent the function, or I call it random variable. Apply to these sample points, so the image is a number. I use a lowercase x1 to denote it. So it's a constant, it's a real number. So random variable x1 map to little x1 for the S. Then another function x2 map to little x2. The same S, the same S. So that is called n-dimensional random variable or n-dimensional random vector. All right? So, it's a discrete random variable if this, remember, although I write it like that, but basically it's just x and y. So this x, y, this point, two-dimensional points, are discrete or finite or countably infinite. Right? That means this x and this y, they are either finite. If they're finite, that means there must be a gap in between the values. All right? Or countably infinite. Now this is very important because the approach that you're going to find the probability, find the expectation, do whatever you want, the approach depends on whether it's discrete random variables or continuous random variables. So here it is. These are the values x1, x2 up to x. Okay. x3 and so on, and y1, y2 up to infinity. All right. Why I use I and j? Can I write it as xi, yi? Why not? Because in that case, 1, if I equal to 1, it means x1, y1. If I equal to 2, it's x2, y2. All right. But how about I have a sample point that may map to this? It's possible. All right. This is just a notation to denote different values. All right. So that's why we use 2 different subscripts to represent the possible outcomes. Now, if this xy random variable or the function takes the value for all values in some region, it's not the whole view planar, it may just be a small region. It takes all the points. Over this small region, there's still infinite number of points. All right. So long as it takes all values, it's very important, all values over some region, then it is considered as continuous. This name Euclidean plane R2, it's just R2, our ordinary R2 plane. All right, and the coordinates are represented by x and y. X from minus infinity to infinity, y from minus infinity to infinity. And this is just part of the R square, or can be R square. All right. Now let's look at this example. Consider we send a television set, a particular television set. All right. So the sample point is the television set. And what's the sample space? The sample space is supposed to be all the television set. Or you can just say that, okay, the television set produced by in certain particular year or a certain brand, but it's understood that we're talking about sample space are all television set. But whether all means maybe from whatever of the first television set up to the television set in the future, we still have television sets. All right. So now we have x to represent the age of the television set to the nearest year. This is important. We are talking about age. And we convert it nearest year. So if it's 1 year and 8 months old, then we consider x equal to 2. X equal to 2. All right? Convert it to the nearest year. So that it becomes just integer. All right? Then y, the same television set, the number of defective components in the set. So x, y represent a 2-dimensional random variable. X is the age, while y is the number of defective components of a given television set. So in other words, for any set is the age, which takes the value, of course, less than 6 months, it can be 0, 1, 2, 3. Theoretically speaking, it can be equal to infinity, while ys, all right, is the number of components, also 0, 1, 2, 3, and so on. Right? This is the age, and this is the number of defective items. So xy is the 2-dimensional random variables, and the range. This R stands for the range of the random variable xy, takes all the points xy, where x is from 0, 1, 2 up to infinity, and y takes the value 0, 1, 2, and the number of defective components in a TV cannot be infinity, still finite. All right. You cannot have infinite components in a machine, so it's finite. So up to n. For example, 5.3 means that the television is about 5 years old and there are 3 defective components in the TV. Here's another example. We have this fast food restaurant, operates 2 facilities. One is the drive-up facility, the other one is walk-up window. So in this case, the sample point is a particular fast food restaurant. And X is how, what is X? X is the proportion of time for this drive-up facility are in use. All right. When we say it's in use, it means that at least one customer is being served or wait to be served. All right. And Y is the the proportion of time that the walk-up window is being used. All right. So the same restaurant, I have 2 possible characteristics. One is the proportion of time that the drive-up facility being used, and the other one is the walk-up facility being used for this restaurant. So the set of possible values is xy, where x is between 0 and 1 and y between 0 and 1. Because we're talking about proportion, you cannot have y beyond 1. We cannot have y less a negative number. It's the proportion of time. So you open that time, whether it's fully used all the time or just part of the time. So it ranges from 0 to 1 for both x and y. X represents the proportion of time used by this particular facility, which we call it drive up or drive in. And then the other one is the proportion of time being used for the walk up window. So it's continuous. Why is it continuous? Because it takes infinite values. It takes all the values within this unit square. All right. So now we have some idea what a 2-dimensional random variable is. So now we want to talk about how to describe the behavior of this 2-dimensional random variable. So it is described by the John probability function or John probability density function. All right. Okay, so for discrete case, we make life easier. So when we talk about discrete, it means that both random variables are discrete. When we talk about continuous, both random variables are continuous. We don't discuss the case where one of them is discrete and the other one is continuous. All right. Of course, we can discuss it, but then for make it easier, so we just talk about discrete random variables. Both of them are discrete, or all of them are discrete, or all of them are continuous. But it does not mean that you cannot have some are continuous, some are discrete. Okay, so for discrete, so we use this, all right, which represent the probability of the random variable takes the value xi and the random variable y takes the value yj. Right. So remember I told you a distribution of a random variable is described by a function. We call it f of x. So for 2 dimension, it's described by a bivariate function, f of xy. So the way that I write it, all right, the subscript, capital X and capital Y, referring to the random variables. So this is a probability function or probability density function corresponding to the random variable X and Y. And inside the parentheses, those are the value of those random variables. And this whole function means that this one, all right, means that now we can forget about the sample space. We talk about xy. So this referring to the random variable xy, or the distribution of xy, And then this one will map with a f of xy to a real number. And this number corresponding to the probability, in this case is probability or probability density. Density. For continuous case, density. All right? So, because of the way that we define it, then this f of xy must be greater or equal to 0. Because the probability must be greater or equal to 0. Right? And this is the hard part. Remember, in the one random variable case, we have sum of f of x equal to 1 for discrete case for all x. So now we extend it, sum of f of xy, sum over j, all right, that means sum over all the possible value of y, and then sum over possible values for I. This has to be 1. So, is this equal to 1? Sum over all the possible sum over j from 1 to infinity. Is it equal to 1? Is it equal to 1? And the answer is no, usually. And in fact, this is simply saying that, okay, I sum up all the probability of x equal to xi and y equal to yj. Sum over j. That means I sum over x equal to xi, y equal to y1. Sum another probability, x equal to xi, and then y equal to y2. And then sum another probability with x equal to xi, and y equal to y3, and so on. So after you sum up all this probability, basically, you are just have the probability of x equal to xi, x equal to xi. So this one does not equal to 1, but instead this one equal to probability of x equal to xi. All right? Okay? Okay. So f of xy defined for all pairs of values for those values that in the range space. And f of x is called joint probability function of xy. So, for the event A, that means xy takes any points, sample points in A, then it just add up all the probabilities of those points that are in A. All right. A is a region, so we defined a region by specifying what are the x value, what are the y values that you want to compute the probability. So you just pick up the points. All those probability related to the points that falls in A, you just add them up. Okay, let's look at this example. I want to find k such that the function, now this is a function in terms of xy and k as well. So it's a function of k and xy. All right? And I want this one to be a joint probability function. All right? So first of all, you have to know what is the range of this function or this two bivariate random variables. All right. It's very simple. What are the values for which this f of x is defined? All right. There are only how many points are? 6 points. X equal to 1, 2, 3. Y equal to 1, 2, 3. No, it's not 6 points. If you remember your multiplication rule, where x equal to 1, y can be 1, can be 2, can be 3. All right, that's what it means. X equal to 2, y can be 1, can be 2, can be 3. So each value of x, there are 3 possible y values. So there are altogether 3 possible values for x. Therefore, it's 3 times 3. Altogether, 9 possible values for the random variable x and y. Okay? So, in other words, what it says is that, in fact, I can write it in a table form. X takes the value 1, 2, 3. Y takes the value 1, 2, 3. And when x equal 1, y equal to 1, the f of x, f11, is k times 1 times 1. This one, when x equal 1, y equal to 2, f of xy is 2 times k times 1 times 2. That means 2k. And this one is k times 1 times 3. All right? So inside the table, each cell represents the probability that x equal to the particular x value and y equal to a particular value. Of course, this one is k times x times y. So in order this function serve as a joint probability function, you need to check two things. Whether this f of xy is greater or equal to 0 for all the xy. All right? Secondly, you have to check, sum up all these probabilities over all possible values of xy is equal to 1. All right? So we have to check. All right? So f of 1, is k, f12 equal to 2k, and so on. So altogether, there are 9 possible values for this probability function. Sum them up, all right, is equal to 36k. So then on k equal to 1 over 36. Because k equal to 1 over 36, so now my f of xy is greater or equal to 0. Because it's, so now I can say that f of xy is greater or equal to 0. Why? Because it's equal to 1 over 36 times x times y, where x is 1, 2, 3, and y is 1, 2, 3. So all these are positive, positive, positive times k, which is positive, so therefore it is greater or equal to 0. When is it 0? When f of xy equal to 0. Remember, f of xy for discrete case represents the probability. So my question is, when the probability equal to 0? Outside the range that I specified. So I should be more specific. So f of xy equal to kxy, where x equal 1, 2, 3, y equal to 1, 2, 3. But outside this range, for example, x equal to 1, but y equal to 10, then what is the probability function? The probability function f of xy will take the value 0 for that. So for those xy value which does not belong to this x equal to 1, 2, 3 and y equal to 1, 2, 3, then the probability function will be 0. Okay, here's another example. So this company has 2 production lines, A and B. A produces at most 5 machines and B 3 machines. So assuming that the numbers of machines produced is a random variable. What does it mean? It means that machine A can produce 0 machine, 1 machine, 2 machine, 3, 4, or 5. It's not every day produce 5 machines. Sometimes it's 0, sometimes it's 1, and so on. Of course, we should, when we say it's random variable, that means there's a probability associated to this number. 0, 1, 2, 3, 4, 5. And similarly for B. All right, so xy represent a 2-dimensional random variable using the numbers of machines produced by A and B on a given day. So the probability distribution function, we can work it out or given to you, and then we asked, I forgot to change this one, not chips, machine. Otherwise, suddenly there's a chip coming in. It should be machine. All right. So basically, to translate it, we are asked, what is the chance that, in terms of the random variable, that the machine, line A produce more machine than B. So the number of machine produced by line A is X. So we are saying that what is the probability X greater than Y? Now this is an important step. Okay, the solution is given to you, but you must able to translate the question. In this case, it's the number of machines produced by line A, okay, which represents by X, and it's more than the number of machines produced by line B. So in other words, translate it in terms of random variable, is the equivalent to saying that X bigger than Y. What is the chance that X bigger than Y? All right? So here, we save one step. You are given how XY behaves. All right? How XY behaves. So from this table, you can see that there are no way that both machines will give you 0. 0, 0, the chance is 0. But there is a possibility that one particular machine does not produce anything on that day, while the other machine produce something. All right? Why is that so? It's because it's given. All right? Make sure that all this probability, or f of xy, these are all f of xy, must be greater or equal to 0, positive. All right? And sum them up equal to 1. All right? Then how about this number? Or in particular, how about this number? What does 0.22 mean? 0.22. 0.22 is the row total. That means we add up all this probability equal to 0.22. So what does it mean? It means that we try to add up all the probability so long x equal to 0. We don't bother what is the y value. We just collect all those probability, all right, such that we don't bother about what's the y value. So long as x equal to 0, we then grab it, add it as part of the probability of x equals 0. So we add probability of x equals 0, y equals 0, plus probability of x equals 0, y equals 1, plus probability of x equal to 0, y equal 2, and so on. So we add up all the probabilities with the same x, but different y value. So that is 0.22. And because these numbers are written on the margins, in this case, it's the right-hand margin, all right? So this is also referred to as marginal probability. This one is the marginal probability of x. X equal to, I'm sorry, marginal of y. I mix up these two, unfortunately, okay? So it's, this referring to f of y. That means when y equals 0, this is the probability. When y equals 1, this is the probability. Right. So obviously, this part is the marginal of x. That means when x equal to 0, this is the probability. When x equal to 1, this is the probability, 0.11. When x equal to 2, the probability is 0.14. So it's the marginal probability. Okay, so now I have these questions. So what is the conditional probability of x given y when y equal to 0? Or in other words, I want to know how x behaves when y equals 0. How x behaves and y equal to 0. All right? So first of all, is this a random variable? It takes more than one value, and there's a probability associated with it. What are the possible values for x? Under y equal under y equals 0, all right, what are the possible values for x? Can x be 0? If I know y equals 0, can x be 0? Why not? Because the probability of both equals 0 is 0. So in fact, x takes the value according to this table. In fact, we just look at this line. So x takes the value 1, 2, 3, 4, and 5. Right? The next question, what is the probability of x equal to 1 when y equals 0? Is it 0.01? Then, if you think it's 0.01, then the next question is, what is the chance that x equal to 2 when y equals 0? I say 0.02, but then you add up all this number, it does not equal to 1. What to do? Divide by this number to make it 1, right? This is how you use brute force to do it. But you have to follow the definition. So what I'm asking is, okay, what is f of conditional when x equal to 0, when x equal to 1, y equal to 0? So this one is probability of x equal to 1 and y equals 0. Divide by what? Probability of y equals 0. That's why you have to divide by 0.22. When I ask, what is this one? When x equal to 1, y equals 0. Then this is equal probability of x equal to 1 and y equals 0. Divide by probability of y equals 0. So that means this number, 2, change it to 2. So that means this number divided by 0.22. That is the probability. This one is the conditional probability of x given y. All right? We'll repeat this again. Just give you some idea. Okay, since I'm talking about the margin, that's called marginal distribution. Naturally, we'll ask, okay, if I know the other variable equal to certain value, like in this case, I say y equals 0. Then how about x? How does x behave? Then we know that x cannot be 0. But x equal to 1, what is the chance? It will not be 0.01. All right? Because in that case, the way that you derive all the probability will not sum up to 1. So naturally, you will adjust it by divide by 0.22. That is one way to look at it. But in fact, I can use the conditional probability that we learned in chapter 1. Then that's why you have to divide by 0.22, which is the probability of y equal to 0. All right? Okay. What we are asked to do, what is the question for this example? We are asked to find the probability of x greater than y. X greater than y. All right? So what is x greater than y? Is this x greater than y? This particular x equals 0, y equal to 2. So x is not bigger than y. So how do I know which one is? Of course, in this case, I already done it for you. Those highlighted in yellow are the points. But basically, just say, think of that. X greater than y. It represents a region. But let's check the boundary first. What is the boundary? The boundary is x equal to y. X equal to y. Unfortunately, the way that I present the graph is different from, okay. I just want you to aware of. Usually, this is the x, this is the y. X equal to y is this line. Where is x bigger than y? X bigger than y. So it's this part, right? Right? All right. But this one is not. This one is on the other line. So y goes downward. It's not upward, so downward. So the line x equal to, okay, maybe x, y equals 0. X, y equal to 1. So this part, all right, these are the cells with x equal to y. Oh, sorry, not this one. Okay, only these three. All right. Then any combination of x, y, that on this side is x bigger than y. How do I know which side? Whether this side or this side? Very simple. Take one pawn. All right? So here, I take one pawn. This pawn, do you know the y coordinate for this pawn? 0, right? What's the x coordinate? Don't care. A, right? Or take it 1. So 1 is bigger than 0. So that means this particular pawn is in the region of x bigger than y. Now if you take this pawn, all right, let's say we know the x coordinate is 0. Y coordinate, let's say, is 1. It depends on 0, 1. Is x bigger than y? No. So this pawn is not satisfy the equation x bigger than y. All right, so this pawn is out. So it's this region. So similarly, you just look at the combination. So it's all this. So you just add up all this probability because each probability satisfies x bigger than y. So you just collect all this probability together. Right? It's very simple. If this pawn gives you x bigger than y, so you get the probability. This pawn x bigger than y, you also get the probability. And you cannot just take one pawn. You have to include everyone, so long as they are satisfy x bigger than y. So that's why I have to add up all this, highlight by yellow, all this combination. I add all this probability. That is my answer. All right? So here it is. Add all these pawns. So the answer is pawn 7-3. So here is another. You have 1 hour in the test, 2 hours in the exam. Think of it, right? Think of it. This one, 1, 2, 3, 4, 4. All right? So altogether there are 14. And this, you have to add up 14 numbers. This one, 1, 2, 3, 4, 4, 3, 2, 1. Add only 10 numbers. So add 10 numbers is easier than add 14 numbers. Not just easier, and the chance of making error is also less. You add 10 numbers, while you add 14 numbers, you may have a higher chance to commit mistakes. So you add the probability of 10 numbers and then subtract from 1. Subtract from 1. But if you have a fast fingers, then it doesn't matter of adding 14 numbers, adding 10 numbers, and it makes no difference. Oh, sorry. This one, okay. Okay, let's look at another example. This time, we have 9 executives. 4 are married, 3 are never married, and 2 are divorced. Make sure that these numbers add up to 9. So there may be a hidden group. If these 3 numbers do not add up to 9. Okay, we choose 3 executives, randomly select, and for promotion. Don't go to this kind of companies. Promotion depends, randomly select. Right? It's just for examples only, all right? Go to a company that promotion depends on your merit. Okay, so let X be the number of married executive. Y is the number of never married executives among the 3 being promoted. All right? Okay, so find the joint probability function of X and Y. So this translate means that you have to find the probability of X equal to X, Y equal to Y. And ask yourself, what are the possible value for X and Y? So how many married persons? So X is equal to can X equal to 0? We're talking about the number of married executives in the being selected for promotion. So it can be 0, right? Yeah, because I can choose the rest. There's still 5 non-married, not married or divorced. So I can choose 3 out of them. So 0 can be 1, 2, 3, 4, 5. No 5. 0, 1, 2, 3. How about Y? Y, never married, 0, 1, 2, 3. Is that all? Okay, these are the possible values. But come to think of it, can X equal 0 and Y equal 0? Is it possible? Hey, you have 9 persons. I want to select 3. 4 of them are married, 3 of them are not married, 2 divorced. So how can I have X equals 0 and Y equals 0? Because if X equals 0, Y equals 0, that means none of these 2 groups will appear in my committee, in my list of promotion. So it's impossible. All right? So remember that. Okay, so how to calculate the probability? Go back to review your chapter 1. So first of all, this is the number of ways that we select 3 out of 9. Disregarding what they are, all right? And to select, all right, okay. I make a mistake. Cannot be 4, right? Yeah, I have 4 married, but then the committee only has 3, maximum 3, right? Okay. If you write 0, 1, 2, 3, 4, and Y equals 0, 1, 2, 3, okay, you can write it like that. But the problem is, I'm going to write down my probability function. This is the one. All right, this is the probability, f of x, y. Or probability of x equal x, y equal y. Right. So it's very simple. I want to have, remember? So now I choose x out of 4 and y out of 3. And then the rest, the balance, 3 minus x minus y. Choose from the third group. All right? Multiply them together, because that is the number of ways that you can choose x from the group of married people, y from the group of never married. I don't know why they don't use the word single. And then the divorced. All right? So that's how number of ways that you can select it. Now, because you write it like that, so that's why I cannot have x equal to 4. Because when x equal to 4, then this becomes negative, no matter what your y is. So it does not, you cannot use this formula. So this formula only valid, at least apparently, only valid when x equals 0, y equals 0, and, x equal to 0, 1, 2, 3, or y equal to 0, 1, 2, 3. But that's not good enough. This is the hard part. You still have this part. What does this mean? It means that x and y together, you must at least contribute 1. What does it mean? It means that I have these 3 for promotion. 2 of them are divorcees. So the one left behind must be from this x or y. Must from the married group or from the never married group. So that's why x plus y must be at least 1. It cannot be 0. X and y cannot both equal 0. At least one of them must be 1. So that means x plus y must be bounded by 1. It's equal to 1. And at the same time, x plus y cannot be any number. All right? Because if you look at this one, x can be 3, y can be 3 if you just use this part. So here I specify that x and y together cannot exceed 3. Why cannot exceed 3? Because that is the number of people in the committee. All right? So in other words, if you choose x equal to 3, then y has to be 0. Because of this. X plus y less or equal to 3. All right? So this is valid only when xy takes the value 0, 1, 2, 3, but cannot be all these 16 of them. So out of this 16 possible combination of x and y, you also have to check these conditions. All right? Okay. So, so the PDF is like this. F of xy, that means probability x equal to little x, y equal to little y is by this. And valid for xy equals 0, 1, 2, 3. But at the same time, x plus y must be between 1 and 3. And for the rest, outside this range, then the probability function is 0. So that is the probability function for this problem. So now I have a question. I have x represent the number of merit executive in the promotion list. Y represent the number of never merit executive on the promotion list. How about I define Z, which is the number of divorced executive on the list? Can I do that? So that means I'm looking at right? So this one, so it's like this. 4 choose X, 3 choose Y, 2 choose Z. Right? But then, when this is valid for a probability function. So X 0, 1, 2, 3, 4, y equals 0, 1, 2, 3, z equals 0, 1, 2. Is this the probability for all this? Can x equal 4 and y equal 3 and z equal to 2? Cannot. You have only a committee of 3 persons. How can you have all 7? So you have think of this formula, when this is valid, to reflect that this is the probability. So now it's very complicated. You need x plus y plus z must be, right? All right? And also, yeah. Right. But this make very complicated because this is a very, very hard condition. So my point is, it's very easy to X, Y, Z to represent all these 3 groups. All right? But in fact, you don't need Z. You see, in my original answer, the third one is choose 3 minus X minus Y out of 2. Here you choose Z out of 2. But it makes it very complicated. All right. The complication lies when this represents the probability. It's not true for all the possible x, y, z values from here. Not true. It has a certain condition applied to it. If you miss one condition, miss one inequality, then your probability function is wrong. So that's why we try not to have so many random variables. In this case, 2 is good enough, just x and y. The last one is 3 minus x minus y. Okay, so here it is. All right. So we can see that so many zeros are there. All right. Remember, we need x plus y bounded below by 1 and bounded above by 3. So in other words, you look at this equation and also look at this equation. This is the equation. How do I know that? This represents a straight line. So how do I know what straight line is it? So we just put x equals 0, y equals 1. X equals 0, y equals 1. So this is a point. All right? a straight line is determined by 2 points. Get another point. When easy lah, then 0, 1 or 1, 0. So x equal to 1, y equals 0. These 2 points. All right, we have 2 points. Draw on it. This is the boundary. All right, for this. Which side? This one is obvious, but which side? Then look at this. So I pick 1, 1. X equal 1, y equal 1. Satisfy this, right? So where's x equal 1, y equal 1? According to my notation here, this is the point. So this point satisfies this inequality. So we are looking at all those values below this point. Right? So I'm working on this part only. Then the next one is this one. So I look at x plus y equal to 3 lah. So x equals 0, y equals 3. So this is the point. 1 point here. X equals 0, y equals 3. And x equals 3, y equals 0. So this is the point. So join them. Which side? Look at, let's say 2, 1. No, not 2, 1. Let's say 1, 1. 1, 1. So 1, 1 is less than, 1 plus 1 is less than 3. So 1, 1 is here. So in other words, we are looking at this one. So any points, 1, 2, 3, 4, 5, 6, 7, 8, 9, satisfy these inequalities. All right. This is the first line. All right. And this is the second line. And anything in between are covered by this inequality. So these are the points that with the probability function given by that form. 4 choose x, 3 choose y, and 2 choose, we choose 3 minus x minus y from 2. And these are the marginal for x. These are the marginal for y. Y takes the value 0, 1, 2, 3, and x takes the value 0, 1, 2, 3 with these corresponding probabilities. All right? Continuous. So continuous is the same thing, except that instead of doing summation, we do integration. So we place by summation over x, summation over y, f of xy equal to 1. So now we do integration over minus infinity to infinity, f of xy, sum over x, sum over y equal to 1. So that's continuous. Are they the same? This range may be just a range of the R square, but it's okay. Because what we say is that outside this range, the probability density function is 0. So in other words, even if you do this one, we'll reduce back to this. All right? Okay. So let's look at this example. So we're given this PDF. And this functional form, valid only for x between 0, 1 and y between 0, 2. Outside that range, the probability density function is 0. So we are asked to find the probability x plus y greater or equal to 1. All right? So, okay, so, but first let's check. You don't have to check if you are not asked, but this one I want to show you that is a properly defined PDF. So first of all, is this greater or equal to 0 for all x, y? And secondly, check whether integrate from minus infinity to infinity of this John PDF equal to 1. So obviously, this one is bigger or equal to 0 because x and y, the range is x between 0, 1 and y between 0, 2. They are all positive. So these are positive. So the first condition satisfied. Second, we have to do the integration. Now for those who not familiar with how to do the integration for two variable case, in fact, it's not that difficult. The problem is so complicated, 2 dimension, 2 variables. I do it step by step. Do one variable at a time. So what we do is fix the other variable. In this case, let's say I fixed y first and work on the x. In other words, I treat y as a constant, all right, and do the integration as if it's just a function of x, all right. So from minus infinity to infinity, the negative values, the PDF is 0, so I can forget about it. For those above 1, x above 1, the PDF also 0. So basically, it's x range from 0 to 1, all right. So after you complete the integration, then you integrate y. So again, for y, only range from 0 to 2. The PDF is equal to this form. Outside that range, it is 0. So this integration is the same as this integration. All right? Now this is an important step. Make sure you do the right thing. So just blindly to do the integration from minus infinity to infinity, you must remember the PDF may not valid from the range from minus infinity to infinity. The PDF equal to this only when x is between 0 and 1. Outside that, it is 0. Integrate 0 is integrate nothing, right? So also for the y, it's equal to that expression only when y is between 0 and 2. Outside that range, the PDF is 0. So integrate this with respect to x, so it's x cubed over 3, and this one becomes x squared over 2 times y over 3, so it becomes x squared y over 6. And then substitute, maybe you better write it as x equal to 0 to 1. So remember, your substitute x equal, the lower limit is 0, upper limit is 1. After a substitute, you don't see any x anymore because we already integrate out the x. So it's a function of y. Then do the integration and it turns out to be 1. So this is just an exercise. The real question is, what is this probability? X plus y greater or equal to 1. So it's like this, okay? X, y. The PDF is valid over this range. You can think of it, the probability density comes out from this plane and only come up from this plane over this region. The rest is still 0, nothing, all right? So x plus y equal to 1. So instead of doing this, I do this one, all right? You will see later why we want to do this one. So x plus y equal 1. Where's the line? X equals 0, y equal 1. X equals 0, y equal 1. So it's here. 1 point. And then when x equal to 1, y equals 0. X equals 1, y equals 0. So it's this point. This is the line. X plus y equal to 1. X plus y less than 1. Which side? This side. Why? You put 0, 0 here is less than 1. So this point should be on this. So in other words, instead of working on this probability, the probability over this region, I work on this probability. Work on this probability. All right. Okay. So the integration is like this. All right. I don't think I have time to finish all this. Maybe I will repeat this example again. But the reason why I pick up this one is that you have a choice to integrate x first or integrate y first. So if you integrate y first, that means you fix x, integrate y. Fix x and try to get all the probability for that x. That means I don't care about what the y is, so long as the x is the same. So I get all the density, concentrate on this point. So you can think of it, I squeeze everything so that all this density here, something come up, will squeeze to fall in this point. So that's the first integration referred to. After that, I'm still not happy. I squeeze it one more time. This time I squeeze the x-axis. So at first I squeeze the y-axis, squeeze in the y direction, squeeze towards the x-axis. So now all the density will be concentrated on the x-axis. Then I squeeze along the x-axis. So everything will be on the point, on that point. That is the answer. All right. So I will continue this Thursday on this example and the rest. Okay. Thank you.